Welcome back. Now let us learn another application of cluster, and that is the finding of outliers using the cluster. And this one we had discussed this point sometime, if you recollect. In case of foundation, if you see on the bottom, I had mentioned that for multivariables you can also use by cluster. Okay, multivariable that using by cluster, that is what we are going to do it over here. So the concept over here is, let me explain to you again. And if you see, this was the things we had learnt during the came-in. So in a simple things, even you have already find it out the cluster. So whichever the point is really far from the center, they are probable outlier. Not necessarily 100% outlier, because you need to do business analysis and it may happen that those are the probable outliers. Since if in this case probably these three are probable outliers, and in this case this one and this probably this one, from the visual point of view these are the probable outliers. Okay, so what we are going to do, we are going to have the center and then find it out the distance of each of the point, and then we'll say okay, let me then we'll see, can we take the set top 5 outlier? It means the top 5 which are the far from the center, and that is what we are going to do over here. So first we are going to find it out the center, and center is already given by the cluster model over here, that fit we did it. So in 126 we are simply extracting the center, and we are trying to modify the center column name. Let me show you why. This is before modification. So if you see that everywhere center dot sepal length and all these things are prefixed. So what we are going to do, we are searching this and substituting with empty, so that at least we get the column name only. Okay, so that is what we are doing in line 127. And 128, we are creating a temporary data frame that is called centers, with cluster ID as one of the column, which we have already got it. Okay, and the centers which you have got were extracted above. So 128 is the center, and the dimension is say 3 row and the 5 column. Why 3 row? Because we have the 3 number of clusters, and the 5 is what? That 4 is the features, and the 5th one is the cluster ID. So let me show you 130. So this is the cluster ID 1, 2, 3, and these are the 4 features, and for each of the cluster these are the centers. These are the centers. Okay, so now what we are going to do, now let us try to have the, before we start taking the distance, let us prepare the data. So let me prepare and then show to you. 133 and 134 we are running together, and let me show the dimension first. So what it is saying, something we have got it this one. So let us see what it is first. Let us see first, we should see what it is first. So what it is this, so it is exactly like our original data, where the difference is the first one is the cluster ID 1, 2, 3, 4. Oh sorry, 1, 2, 3, and these are the 4 features we have it, and these are the center. Because when we take the difference, what we are trying to make, original data we have 150 row and the 4 column, and here we have make a temporary data table. So 133 we are making a data table first with cluster ID, that is this one, and then merging this our temporary data table with the center above which we created by cluster ID. Okay, and no need to short it, otherwise that sequence will change. So for each of the cluster we are getting the 150 row, that is what if you see in line 36, 150 row and the 5 column. So now we have a temporary data table with similar structure of our original data. And now we are going to take the distance. And I hope you remember the Euclidean distance, that this is our actual data minus, and this is the center data. And we have said minus 1. What is the meaning of minus 1? Minus 1 means do not take the first column. Okay, do not take the first column. So if you see, I'm just printing that much so that at least you can see. See, with that, this is minus 1 means with all the column except the first one. Okay, and so this is the difference of this one. Then taking the square of that, summing it up, and then taking a square root. This is what is there for this is Euclidean distance. So let us run the line 140. So this is the distance of each of the point from the center. Let us see the head of this one. So these are the sum unit. Okay, and if you see the summary, so summary means it is showing you that what is the minimum, maximum, and all. It is simply, that's all. And dt is the temporary data table we have made it, where that is the first column is cluster ID, remaining 4 are center, and distance we are making in the 143. So we are getting the distance in the temporary data table 143. That's all. It means now the data is ready. So before now start getting into finding out, so how can we find it out? Let us find it out the distance or change the order of the distance in decreasing order. So what it means that maximum will be on the top and minimum will be on the bottom side. So this will be the probable list of the outliers. So 146 is the ordering of distance, highest on the top and the going down. So if you say that now outlier is there, and outlier simply say that I want say 75 percentile and above. So that is my outlier. So you can go ahead and do it in that way, and this is how the 75% it will come. It will come. So what it is going to do, if you want to go ahead with the quantile, so you can go ahead with the quantile. Let me put it over here, because this may confuse you sometime. So there are multiple ways to find it out outlier. So says suppose you say that top 25% is my outlier, probable outlier. So here we have got it, that what is the cutoff in 146. So this is the cutoff of the 25 percentile, top 25 percentile. Some number is there, and what we are doing, we are simply generating a color call if something is greater than 75 percentile as a red and else blue. That is what we are doing in line 147, and we are plotting the distance with color, the color which we have got it. So let us plot it, line 148. So this is the plot. If you see, so what it is saying, that whichever that red one is a bit having the higher distance. So overall, right now it is not showing for which cluster, but what it is trying to show you that all these red one, if you see, all these on the higher side, and probably these points and these points from different cluster. Okay. Now this is the one way to find it out. That is for the quantile. There is another way for the top 5. So top 5, let's say that we have already got this outlier in order. So if you see this, I'm just printing this outlier. So line number 118 is having highest distance from its center, then line 132 and so on. So 154 we are seeing top 5, and depending upon the color, so whichever is mapping, the top 5, we are making it red and remaining blue. So 156 we are printing again, and if you see, so only the top 5 is having as a red. So this is the one of the way to get it. Okay, and now what we want you to do it. Till now we haven't considering the overall data. Okay, now for each of the cluster, so this is for each, this is for overall data. So now please do it for each of the cluster. So say top 5 for each of the clusters. This is what the class work. So plot cluster. So let me write it again. Plot cluster with large. So here for each of clusters, this is plot. Okay, for each of clusters, please do that. So this will be, so right now it is having say 150. So each of the clusters, so let's say the cluster 1 is 50 points. So this will be only 50 point, and for that 50 point, show me the top 5 outlier. Okay, so this will be your class work. So please, now I'm going to end this video. In line 160, I'm closing it, clearing it the memory, and please do the class work so that you can really understand how the really works out. Okay, thanks a lot for watching this. See you in the next one.